Okay, according to statistics, a person will devote 34 years to sleeping and watching TV. The number of years sleeping will exceed the number of years watching TV by 17, or watching TV by 18. Over the lifetime, how many years will the person spend on each of these activities? Okay, so let's pick a different color. So basically, if we look at the first one, a person will devote 34 years to sleeping and watching TV. We could make an equation that looks sort of like this. Sleeping, and then we'll say watching TV as W. If we add those two together, we should get a total of 34 years. The number of years sleeping will exceed the number of years watching TV if we look at that second bit. The number of years sleeping will exceed the number of years watching TV by 18. So sleeping, we're actually going to do more of that than watching TV, just on average. So we could say a second equation, sleeping is going to be equal to watching TV, but we have to actually add 18 to the watching TV since there's 18 more years of sleeping. So as long as we can come up with that, then we should be able to solve it. If we've got S equal to W plus 18, what we could do is just take this W plus 18 part, substitute that in that first equation, and then solve it from there. Instead of S, we've got W plus 18, and then plus the W equals 34. So all we did was replace the S. Here we can put our like terms together. We've got W and W. That makes 2W plus 18 equals 34. Let's shrink this a little bit. And subtract 18 from both sides. Bring down our equal sign. We got 2W equals 16. Divide both sides by 2. W equals 8. So we've got W equals 8, and we just need to figure out what S is. And we knew earlier, and let's do this in green. We knew earlier that S was equal to W plus 18. So if we know S is equal to W plus 18, we know that S is equal to, now W we know is 8 plus the 18. 8 plus 18 is 26. Okay, so we're going to sleep 26 years and then watch 8 years of TV. Pretty encouraging. Next up, suppose the average yearly salary of an individual whose final degree is a master's is $52,000 less than twice that of an individual whose final degree is a bachelor's. So if we just look at that first sentence, actually let's read the second one. Combine two people with each of these educational attainments earn $122,000. Find the average yearly salary of an individual with each of these degrees. So if we just start with the first sentence, an average yearly salary of an individual whose final degree is a master's degree is $52,000 less than twice that of an individual whose final degree is a bachelor's. So the master's degree, we'll go ahead and say M is equal to $52,000 less than twice a bachelor's. And anytime you see this phrase less than, it does indicate subtraction, but the thing here, when you see that phrase less than, the subtraction is going to invert the order of the things as they're read. So this 52,000 less than, we're going to have subtraction, but the 52,000 is actually going to go second. So 52,000 less is going to look like that. Less than twice that of an individual whose final degree is a bachelor's. So twice a bachelor's degree. So we could go ahead and write that as 2B. Okay, so 52,000 less than twice a bachelor's degree is what a person with a master's degree will earn on average. And then it also says combined, two people with each of these attainments earn $122,000. So we could make another equation. M plus B, if we were to add their two earnings, master's plus the bachelor's, the total would be $122,000. Okay, and then solving this is pretty similar to solving the last equation that we did. Since we know M is equal to 2B minus 52,000, we can just take that and plug it in the other equation for M. So now we've got 2B minus 52,000, and then plus B equals 122,000. And then we just have to solve that, and we'll be able to figure out what B is. Start out putting our like terms together. 2B and B is 3B minus 52,000 equals 122,000. Let's shrink this a little bit. Trying to get the B by itself, so we'll add 52,000. Bring down our equal sign on the left. Now we got 3B. On the right now we've got 0, 0, 0, 4, 7, 174,000. Divide both sides by 3. Divide that side by 3. We get B equals $58,000. Okay, so we've at least got that bit. If they're looking for the bachelor's degree, and we know that a master's degree is going to be 52,000, less than twice a bachelor's degree. So we could do it that way. We could also do this M plus B equals 122,000. Either way. If we follow this over, we know 2 times B, which is 58,000, minus 52,000 is going to be what a master's degree earns. So 2 times 58,000 116,000 minus 52,000. Okay, so that ends up being $64,000. And that's how much a master's degree will earn on average. So not a huge difference, but over a span of time, it does add up to a lot. Next up, according to the National Center for Health Statistics, in 1990, 28% of babies born in the U.S. were born to parents who were not married. Throughout the 1990s, this increased by approximately 0.6% per year. If this trend continues, in which year will 67% of babies be born out of wedlock? So we're starting at, in 1990, at 28%. So here we are at 28%. We'll put 0.28 to represent that percentage. And it's going to rise each year 0.6%. So we're going to be adding, we'll say 0.6, or let me take that back. Okay, so we'll start over again. We're starting at 28%, so we start at 0.28 in 1990, and we're going to be adding 6%. And you have to be careful when you write this 6% as a decimal, because it is a decimal, but anytime you change, like for instance, the 28%, we move that decimal back 2 spots, changing it from a percent to a decimal. So with the 0.6%, we're also going to move it back 2 spaces also to make it a decimal. So this is going to be 0.006. And every year it's going to raise that much. So we're going to take that 0.006 times x, since we don't know the number of years that it's going to be. So if it's 2 years, then we're just taking it times 2, but we're going to see how many years it takes until we get to 67%. So we could just make that 0.67. We'll see how many x we need, how many years we need. So we'll start off just working this out like a normal algebraic problem. We'll subtract 0.28 to get that x term by itself. So we got 0.006x equals 0.39. And we'll divide both sides by 0.006. And we get x equals 65. Let me put that in our calculators. So it's asking in which year will 67% of the babies be born out of wedlock. So it's actually going to take 65 years to get there. So if we're starting at 1995, or 1990 rather, we're going to go another 65 years before we actually get there. So 1990 plus 65, that's going to give us 2055 before we get there. Next up, a new car worth $18,000 is depreciating in value by $3,000 a year. So it's going down in value by $3,000 a year. Complete the following parts A and B. Write a formula that models the car's value Y in dollars after X years. So the amount that it's worth is equal to where it starts, which is $18,000. And it's going to depreciate. It's going to subtract $3,000 every year. So the year we're writing as X, so 3,000 times X. If it's 2 years, then that means it's gone down $6,000. If it's 1 year, that means it's only gone down $3,000. Then we're going to use the formula from part A to determine how many years the car's value will be worth $3,000. So Y actually represents the car's value. So it's saying how long till the car's value is $3,000. So instead of Y, we're going to put in 3,000 and then just leave X because we'll figure out what that is. So 18,000 minus 3,000 X. Okay, so to solve this, we want to get, let's use green. We want to get the X by itself, so let's start off getting rid of this 18,000. That's going to give us a negative number. Bring down the equal sign. We got negative 15,000 equals, and this is a negative 3,000x is all that was left on that side. Divide both sides by negative 3,000 in order to get that x by itself. And we get x equals negative 15,000 divided by negative 3,000. Just a little reminder, anytime you've got a negative divided by a negative, that makes it positive. And 15,000 divided by 3,000 is 5. So that's not a whole lot of time. In 5 years, it goes from being worth 18,000 to being worth 3,000. You are choosing between two health clubs. Club A offers membership fee of $15 plus a monthly fee of $17. Club B offers membership for a fee of $11 plus a monthly fee of $19. After how many months will the total cost of each health club be the same? what will be the total cost for each club? So if we're going to set this up, Club A, we know they offer a membership fee of $15 plus a monthly fee of $17. So we're going to take that 17 times the number of months that we're going there, which at this point we don't know how many months it is. So 17 times X. If it's 1 month, it's just going to be $17 plus the $15 club fee. And we're saying, when will this, after how many months, will that be equal to the other club, which was $11 plus a monthly fee of $19 per month? Okay, and then all we've got to do is solve that. Ultimately, we want to get the x's on the same side, so you could do this a variety of ways, but I would start by subtracting 17x from both sides. Bring down the equal side. On the right side, we got 11 and then plus 2x. On the right side, we've got 15 and want to continue working to get that x by itself, so we've got to get rid of this 11 from both sides. The 11s cancel on the right, and we're just left with 2x. And on the left side, 15 minus 11 is 4, divided both sides by 2, and x is equal to 2. So in other words, 2 months, and the fees will be the same. So, and it also says, what will be the total cost for each club? So if it's going to be the same, so we only have to figure out one of them, and it's going to be equal to the other. So we could do 15 plus 17, and now we know x is equal to 2. So 17 times 2. In other words, 15 plus 34, which is going to be $49. Next up, the bus fare in a city is $1.50. People who use the bus have the option of purchasing a monthly coupon for $22. With the coupon book, the fare is reduced to 50 cents. Determine the number of times in a month the bus must be used so that the total monthly cost without the coupon is the same as the total monthly cost with the coupon. So it's saying we're going to be setting two things equal to each other. We're saying, when is this thing on the left, the cost of using the bus without the coupon book, that's going to be $1.50 per use. So we'll go ahead and say X number of times. When is that going to be the same as purchasing the coupon book, which is $22 right off the bat, and then you're spending 50 cents per ride, so 0.50 times the number of rides. So once we've got that, just solving it, we want to get the x's on the same side. I would go ahead and subtract 0.50x from both sides. That cancels the x's on the right. Bring down the equal sign. We've got 22 on the right. And on the left now we've got 150 minus 0.50 is just 1. So we've got 1x equals 22. In other words, x equals 22. So not too complicated there. And 1x is just the same as x. So x equals, you're going to have to use the coupon 22 times in order for it to all balance out. Next up, in 2006, there were 12,500 students at College A with a projected enrollment increase of 1,200 students per year. In the same year, there were 32,900 students at College B with a projected enrollment decline of 500 students per year. According to these projections, in what year will the colleges have the same enrollment? What will be the enrollment at that time? So we've got two things that we're answering. And so we sort of have a similar situation, we're saying when will these two things be the same? So we're setting up things to be equal. In college A, we're starting at 12,500 students, and we're increasing 1,200 students per year. So 1,200 times the number of years, which we don't know right now, we'll just let that be X. And then when is that going to be equal to college B, which starts with 32,900, and it is decreasing. Where does it say that at? Projected decline, so that's decreasing 500 students per year, 500 times X. Okay, so college A and its projection, college B and its projection, and we just solve those. Want to get the X's on the same side, I would probably move this 500X over, so we'll add 500X to both sides. On the right, those X's are going to cancel. So now we've got 32,900 on the right. On the left, we've got now 1,700X and this 1,250, or 12,500 rather. Still doing some work to get the X by itself, so we want to get the X term by itself. We'll subtract this 12,500. So we've got 1,700X on the left, and on the right, we've got 20,400. Divide both sides by 1,700. Let's shrink this a little bit. And hopefully this comes out nicely. We've got X equals 12. And so that we've got to be careful. That's not necessarily answering our question. It says, in what year will the colleges have the same enrollment? So it's going to take 12 years for them to get there. And since we started up here in 2006, if it's going to be another 12 years before we get there, 2006 plus the 12 years is going to take us to 2018. So that answers the first part of the question, and shrink this a little bit more. The second part of the question, which was saying what will the enrollment be? So if it's going to be in 12 years, we could look at either one of those enrollments. In college A, started with 12,500 plus it's going to add 1,200, and over the course of 12 years, we just multiply 12. So 12,500 plus 14,400 is going to give us 26,900 students enrolled at that time. Next up, after an 85% reduction, you purchase a new DVD player on sale for $78. What was the original price of the DVD player? So just like anytime you purchase something on sale, it starts at an original price. So that's what we're looking for. What was the original price? We'll let that be X. And it's going to go down by 85%. So it's going to decrease by 85%. Anytime you put a percent into an equation, you need to write it as a decimal. So 85% is the same as 0.85. And you'll want to be careful here because since we're talking about money, if we leave it like this, subtracting 0.85, that would mean 85 cents. So we want to be careful we don't leave it like that. What we want to do is make it 0.85 times x, and that means 0.85x in contrast means 85% of the original. So we're taking the original and we're subtracting 85% of it, and that's how we're getting the $78. Okay, so this is just kind of a side note. And then we just want to put our like terms together. You might remember that there's a 1 in front of that x there. So we've got 1x minus 0.85x. So when we put those two together, we get 0.15x equals 78. And then we're just going to divide both sides. Let's do this in pink. Divide by 0.15. Divide by 0.15. And when you put that in the calculator, be careful that you don't divide by 15, because this needs to be 78 divided by 0.15, which gives us 520. So that's quite a decrease, and it's an 85% reduction, so that should be what we expect. So from 520 to $78, a decrease of 85%. Next up, including a 6% sales tax and end charges, $145.22 per night. Find the end's nightly cost before taxes added. So we're looking for the cost before taxes added. So it starts in the beginning at X, and then we're going to add a 6% sales tax. So 6% is 0.06, if you're remembering. We're moving that decimal back 2 spaces. And again, we're not just adding, since we're talking about money, this can't be 6 cents. We're adding 6% of whatever the original cost was. So after adding the 6%, we equal $145.22. That's how we get our final fee. And then from there, it's just like the problem that we did just previous to this. So 1x plus 0.06x. So here we're adding these. So we've got 1.06x. When we put together those two like terms, equals 145.22. And we want to divide to get the x by itself. And we get x equals 145.22 divided by 1.06 equals 137. And that seems reasonable. That's where it started at. They added sales tax and they ended up at 145.22. Okay, you invested $26,000 in 2 accounts paying 3% and 8% annual interest respectively. If the total interest earned for the year was $1,530, how much was invested at each rate? So for this one, we're going to, there's a couple different ways we could go about approaching this. Setting up 2 different equations is probably the best way to do it. We invested $26,000 in 2 accounts. One account earned 3%, and the other account earned 8%. So just right off the bat, we've got 2 accounts. We don't know how much we invested in either one of those. So just in simple terms, if we invested X in the first one and we'll say Y in the second one, we know our total investment is $26,000. We made 2 investments totaling $26,000. One of the investments earned 3%. So if we just deal with the first one, let it be 3% we're earning on that one. So 0.03x, that's how much we're making on it. And the other one is 8% annual interest. So 0.08y for that one. If we add those 2 interests, we get a total of $1,530. And really, at this point, that's enough to solve this. We just have to get one of these x's or y's by itself, because the 2 equations that we've got have too many variables to solve it. But if let's look at this top one, for example. If we, let's say, subtract y from both sides, then we'll get the x by itself. These y's would cancel out, and we'd have x equals 26,000 minus y. And the reason that helps us is because we can then take what x is equal to, this 26,000 minus y, and we can put it in the other equation for x. So now we've got 0.03, and instead of x, we're multiplying this 26,000 minus y. So I'm going to go ahead and put that parentheses. 26,000 minus y, and then we'll go on and write the rest of that equation. Plus 0.08y equals 1530, and this should be enough to solve it. Going to distribute that to both of those. 0.03 times 26,000. And then 0.03 times negative y. Put together our like terms. We've got 780 plus 0.05y equals 1530. And we want to continue doing some work to get that y by itself. So we'll subtract 780 from both sides. Bring down the equal sign. We got 750 on the right, 0.05 y on the left, and we'll divide both sides by 0.05 to get that y by itself. So we'll get y equals 750 divided by 0.05 equals 15,000. Okay, which seems reasonable if we know we invested a total of 26,000. One of the investments happens to be 15,000. That was the one at 8%, since this is y. So let me highlight that. So the one at 8% y is 15,000. And if we want to figure out what the other one was, we knew that x was equal to 26,000 minus y. So if x is equal to 26,000 minus y we know now is 15,000. That means that x is 11,000. Okay, those do both add up to be 26,000. And keep in mind that x was the one that was at 3%, just in case you're asked to put them in with the right percent. Next up, the length of a new rectangular playing field is 7 yards longer than triple the width if the perimeter of the rectangular playing field is 446 yards. What are its dimensions? So the length is 7 yards longer than triple the width. So if we were looking at this first sentence, the length is 7 yards longer. 7 yards longer is going to be addition, so we could say the length is equal to 7 yards more than triple the width. Triple, it means 3 times that thing. So 7 yards longer than 3 times the width. And then the second bit, if the perimeter of the rectangular playing field is 446 yards, what are its dimensions? Perimeter, we've got a formula for that. Perimeter is equal to 2L. This is the perimeter of a rectangle, plus 2W. And in this case, we can replace that perimeter, that P, with a number that's given to us. We're told that the perimeter itself is 446 yards. Anytime they talk about the perimeter of a rectangle, you're more than likely going to use this formula. And then next up, the reason we can't solve either one of these equations on its own is because it's got two different variables. If we only had one variable, we could solve it. So if we look at this first equation, we've already got L by itself, so we could take what L is equal to and plug it in for L. So now we've got 446 equals 2L, but instead of L, we'll put in 7 plus 3W. And then write the rest of that equation. We'll need to distribute. So 446 equals 2 times 7, 2 times 3W, and then the plus 2W. We got some like terms there. So 14 plus 8W equals 446. And then we want to do some work to get the 8W by itself, so we got to get rid of this 14. So subtract 14 is going to cancel that. Subtract 14 from both sides, bring down the equals. We've got 8W on the right. On the left, we've got 432. Divide both sides by 8. And we get W equals 54. Okay, and we want to find both dimensions. So earlier we knew that L was equal to 7 more than triple the width. So that means it's 7 plus 3 times W, which we know now is 54. So that's 7 plus 2, carry the 1, 162. So that is 169 for the length. Okay, these next couple problems should be a little bit more straightforward. Solve the formula for Q. So we've got A equals W plus QG. So it might seem a little strange. We're not working with numbers now. We're just working with letters. But the processes are still the same. We want to get the Q all by itself. So we want to start off getting the Q term by itself, which means we need to get rid of this W. So it'll look a little weird, but on the left, A and W, those aren't two terms we can actually make into one, so we just need to write this as A minus W equals, and on the right side, the W's cancel, and we were just left with QG. And since those two are multiplying, all we've got to do to get that Q by itself is divide by G. The G's will then cancel, but we've got to divide the entire other side by G also. So we end up with, bring down the equal sign, we've got Q equals A minus W over G. So it looks odd, but that is our solution. Next up, pretty much the same thing. Trying to get the T by itself now. Pretty much the same process. So we want to start off getting the T term by itself. So we're going to subtract P to get rid of that part of it. Bring down the equal sign. Now on the right, we've got PRT by itself. And on the left, M and P. Those weren't two things we could put together. So we've got M minus P. And then we want to continue to get T by itself. So T is being multiplied with all the things on the right, all the things with it. So in order to separate those, we got to do the opposite of multiplication, which is divide. So we're going to divide by P and we're going to divide by R. The P is going to cancel and the R is going to cancel. We'll just be left with T. But on the other side, we've also got to divide by P and R. So on the right, we've got T, and on the left, we've got M minus P over PR. Okay, so we do want to go a little bit farther just because we've got a P in the numerator and we've got a P in the denominator. So we can simplify this a little bit, just like the directions seem to indicate. What we can do is, let me erase a little bit. Take both terms on top and put them over the denominator. So we've got M over PR, and we'll subtract P over PR. And that'll equal T still. And the way we're going to simplify this a little bit further is you might notice that the P's will cancel each other in this case. And we'll be left with, let's do this in blue, M over PR, nothing's going to cancel in that first fraction, minus, we just have R on the bottom, and since everything on the top canceled, we've got to go ahead and put a 1 there. Equals T, and that will actually be our solution. Okay, and then this last one, solve K equals 2LM plus 2LN for L. And in this case, you might notice that two terms have an L. So what we'll need to do is, they're already on the same side, so what we can do is factor out an L. So what we'll do is we've got K equals 2LM plus 2LN, just rewriting this, and we want to factor out an L. When we factor an L, we've got K on the right, or left rather. When we take an L out of the first term here, we're just left with 2M. When we take an L out of the second term, we're just left with 2N. And from there, it's pretty straightforward. If we want to get the L all by itself, since L is being multiplied by this 2M plus 2N, we just divide by 2M plus 2N, and we have to do that on both sides. The 2M plus 2N's will cancel on the right, and now we've got L equals K over 2M plus 2N, and that is it.